Okay. All right, so we're going to come back to 2.2, and we're going to jump right to section 2.3. So section 2.3 is basic. So it's going to get harder, but basic. And we've got all semesters to do differentiation rules. Spell this right. Differentiation rules. That means shortcuts so that we don't have to do limits. Shortcuts so that we don't have to do limits. Right? And the most basic is called the power rule. And that's the one we're going to use every day. The power rule says, if I have f of x and it equals x to some number, instead of doing limits and everything like that, the derivative, remember this notation is derivative, is equal to this exponent rolls down in front as a coefficient, n times x to the n minus 1. So you will hear me say the rest of the semester, roll it down, subtract 1. When I say roll it down, subtract 1, we are doing the power rule. Okay? The power rule, roll it down, subtract 1. Roll it down, subtract 1. Now, we could also write it, just let's talk about, you don't even have to write it if you don't want to, but just different notation. Remember, what does this notation mean? Find the derivative, right? So I could write it like this, and notice it'll just be a little bit less notation. If I say, hey, give me the derivative of x to the n, you see how I can just make it as one thing then, and I can say, hey, the derivative of x to the n is roll it down, subtract 1. So that's just a different way to write it. Might as well have two ways to write it if we're going to be doing it every day. So let's use that. Okay, so that's the power rule. This is called the constant rule. And that says, what happens if I want the derivative of, there's a number out in front. A c is a constant, a number x to the n. It's the same thing. You're still going to hear me say roll it down, subtract 1. What do we do though when we roll it down and there's a number already there? You multiply. So it's going to be c times n, because I rolled n down, and then x to the n minus 1. And we're going to do these, so don't panic, but at least gives you something to reference. Okay, how about, we got two, I think just the two more rules, and then we'll go to a bunch of examples. So let's do let's go to a new page. All right, so let's go to the sum rule. Should be able to see that, yeah. Okay, sum rule says, if we're talking about taking the derivative of f of x plus g of x. Now, you can think of this as two separate functions. That's okay, because that's technically the notation. But this also means just each term. You can also think of it as each term. When you're adding, you take the derivative of each term. So this is going to be equal to, see if I can squeeze it out. You take the derivative of the first term, and then you take plus the derivative of the second term. All right, and you can do the same thing for subtraction. So the difference rule. The difference rule, if we're taking the derivative and we're subtracting. Again, really the only way they can write it is it looks like it's two functions, and you can think of it as two functions, but really what they're talking about here is individual terms. And it is okay to take the derivative of each individual term minus, and then the derivative of, I'm so worried about the way this looks. What is this supposed to say? G of x. Yes, go back and change that. Sorry, guys. G of x. And this one should say G of x. I'm just so used to writing that. Okay, so back that up a second. Do we see how this is just saying take the derivative of each term? Okay, make sure you change that to G of x, f of x, and then G of x. Not the case for multiplication or division. We got more rules that aren't so basic. Okay, so remember how I was applauding multiplication all semester long? Okay, now we hit the brakes. He's not a perfect child either. Okay, so now multiplication and division are going to give us a little bit of a headache. Finally, he's not perfect. So we're back to enjoying addition and subtraction. All right. All right, so let's put into play now with numbers. Let's do, okay, the directions, the rest, we're just going to do a bunch of examples. Differentiate the function, which basically is saying find the derivative. Find the derivative. If you want to put that in parentheses, find the derivative. Or if you just want to listen, that's fine. But find, it means the same thing as find the derivative. Okay, so if I give you f of x equals x to the 7th. Now, the first day, well, maybe not the first day, because the first day we were given a number. So yesterday, what would we have done? We would have said the limit as h approaches 0 of f of a plus h minus f of a all over h. And that works. It's just, this starts to get to be annoying with a 7th, because I've got to do a plus h to the 7th minus a to the 7th all over h. And that's going to be a little hard to work with. So I'm going to put like this, and I'm going to say continued, right? Because we're nowhere near done. That's going to be a little crazy. Or what could we now do instead? Instead of doing the limit, which we just pulled our hair out for 2 days, what could we do instead? Roll it down. So it's going to be 7 and then x to the 7 minus 1, or 7x to the 6. Same thing. It gets us the same exact answer. So you can choose. I think this one's a little bit easier. You will have to do one of these on the test, but it'll be one that we kind of covered in class. But I am going to have you do one where you have to do the limits. But understand that this, where was it? This power rule is taking the place of the limit, okay, instead. All right, how about if f of x equals 5x to the 3rd? I could do limits, or I could do my shortcut. What's the derivative? Roll it down. Now, what do? I roll it down if there's a number there. Multiply. This is that constant rule. I have this 5 as a constant, so he just tags along as multiplication. And then I subtract 1. 3 minus 1. If you want to go right to 2, that's fine. Take advantage as short as, as basic. There'll be some times when there's fractions that I'll write minus 1, but eventually you can just write 2. So the best answer then is 15x squared. Okay, let's go back to the one we did yesterday. Y equals 2x squared plus 4x. Oh, we haven't done this yet, have we? Let's wait. Well, let's wait with that for a minute. Let's do this one. Let's just do y equals, let's just talk about 4x. And we'll put it all together. I guess we could have done it all together, but sometimes it's just nice to break it down first. This might be one where I want to write subtraction because I roll it down. What number, first of all, am I rolling down? A 1. Okay, so technically 4 times 1, there's a 1 there, and then I'm supposed to subtract 1. This has a 1 here. 1 minus 1 is 0. And 4 times 1 is 4. What's anything to the 0 power? Anything to the 0 power is 1. The whole thing, not the exponent, but the whole thing. This is 1. So 4 times 1 is 4. So an x to the first, the x simply goes away when you're doing the derivative. An x to the first, the x will go away. Let's label this. This is the derivative. Let's use, since I did y, let's do this notation. Okay, we're doing all our different notations here. So this shows the derivative. I guess we just changed, instead of f of x, it's y. All right, how about, let's do one more and then we'll come back to this one. What happens if it's just a constant to begin with? Technically, you can think of this as 8x to the 0. So what happens when I roll my exponent down? I get 8 times 0. Yes, I should maybe subtract 1. Subtract 1. And so I get x to the negative 1. But what's 0 times anything? 0. So all x's just gives you the coefficient. All numbers go to 0. All numbers go to 0. All x to the first just go to the, notice this was my coefficient of 4. That's it there. My number will always go, let's mark this as a derivative. Numbers will always go to 0. Numbers always have a derivative of 0. Okay, so now let's put into play. Let's go back to the last one we did. Let's do y equals 2x squared. This was the last one we did yesterday. Okay, now we're kind of implementing that other rule. It's okay, as long as we're adding, it's okay to do the derivative of each term. We're going to do the derivative of each term. So the derivative, let's mark it right away. Let's do just the derivative of this guy. Roll it down, subtract 1. Roll it down, subtract 1. What do I do if I roll it down and there's a number there? Multiply. So 4, and if I subtract 1, that gives me x to the first. Plus, all right, what's the derivative of this guy? 4x, the derivative is going to be 4. And then you don't have to necessarily, you can take the sign with, I guess. Here I split it up, but probably better to take the sign with. What's the derivative of a constant? 0. So we could do plus 0. We don't really need that. So we got the derivative to be 4x plus 4. What did we get yesterday when we did limits? 4a plus 4, and we said that a is really going to be an x anyway. So do we like yesterday's or today? All right. But we want you to at least see where limits come from. So limits now are going to kind of fade out, and we're just going to, but now we got to remember all these rules. Okay. All right, how about, did that. Okay, let's do, should we do a long one? Let's do f of x equals x to the 8th plus 2x to the 5th minus 5x to the 4th minus 6x plus 5. Directions are find the derivative. Find the derivative. We're so thankful, and remember we loved polynomials, and we like polynomials because we can take the derivative of each term. That's no problem at all. Once we get into multiplying, then that changes everything, but for polynomials, we're just going to take the derivative of each term. Anyone want to try it? All right, go ahead, John.
7x to the 7 plus 10x.
Okay, now hang on. That first one, you're close. I like the x to the 7th. Just make sure you roll it down. So it's actually 8x to the 7th. Roll it down first and then subtract 1. But you did it on the next one. So the next one was, you were right. The next one is, okay, yeah, no, one before that. Yes, and so you roll down the 5. Beautiful. 10x to the 4th. Perfect. All right, keep going. Then negative.
Well, I thought it was negative 5 being done by 4.
Yeah.
That would be positive, right?
Nope. A negative 5 times a negative times a positive is negative. Yeah. So negative 5 times a positive 4 will give us a negative 20, and then x to the 3rd. Beautiful. All right, and then negative 6, and the 5 goes to 0. Now, what is this? That's the answer. What does that answer do? Why do we care about that answer? That will find us slope. That will find slope on f of x. So it finds me slope on this graph. You just give me an x value, okay, or what our book would have called an a value. I want slope on this graph when x is 2. I actually plug it into this equation, and that'll give me the slope. I want the slope on this graph when x is 7. How am I going to find the slope when x is 7? Plug it into the derivative. The derivative finds you the slope. All right. Okay, let's make them a little bit harder. All right. How about f of x equals 1 over x squared? We don't like division. We're not ready. There's a whole other rule. And even when we have division, if we can get rid of it, all the better. Where can I put that x so that I don't have division? Move it to the numerator, so this is still f of x, making the exponent negative. Remember that first day I said fill in that chart? We're going to be working with exponents every day. Here we go. No turning back, exponents every day. So we want slide that to the top, make that exponent negative. Now, as far as taking the derivative, roll it down, subtract 1. Just be careful. This is, I still take the time to write -1 because the answer is -3. Okay. This is not a waste of time. As soon as you see it visually, you'll get it right every time. If you try to do it in your head with the negatives, because there's so much going on, you'll mess it up. But now make sure what goes down in front. Roll it down first. So -2, then do the subtraction, -3. If you want to now slide the x back, you could because it's negative. I'm okay with an answer like that. That's perfect. Notice the 2, just because it's negative, it stays. The only time you slide something is if the exponent is negative. So I could put the x down back into the denominator and make it a +3. But you don't have to. This answer is okay. But just to kind of get you thinking, a lot of kids see that -2 and they want to slide that. It's only if the exponent is negative. So we could put or either one. All right, what is that? That's the derivative. What does the derivative give us? Slope on the original. If I want slope when x is 2, I can go find it. I can find the point here. If I want the slope, I plug it into this one. All right, how about f of x equals the cube root of x squared? In order to use the power rule, you need a power. So that's why we had to be able to write it as an exponent. Power slash exponent, right? The same thing. So first, this is just f of x. How can I write it with an exponent? Do you remember which way it goes? 2/3. 2/3. The exponent goes on top, the root goes on the bottom. All right, now I can still roll it down. Now I can actually take the derivative, roll it down. So 2/3, a fraction's okay. X to the, now just take your time, -1. Okay. If you need a calculator or you just want it, make it go easier, that's fine. Otherwise, you have to get a common denominator. 2/3 minus 3/3, because that's 1. So that would give you -1/3. But a calculator more than 5. Stuff kind of all over. There's fractions all over the place. So just so that you can see that this -1/3, are we okay? That's the exponent. I kind of wrote it out there. And again, that answer is fine. That answer is fine. Let's just rewrite it so we get comfortable moving things around. 2 could go on top. The 3 could go on the bottom. This exponent's negative, so if I slide it down, I can put it on the bottom. And because it's an exponent of 1, but a bottom of 3, that's a cube root. Just so that you get used to kind of seeing things. So you're going to have to be sliding things around. You don't have to. This answer is fine. But the more comfortable you feel rewriting stuff, the better. So we can put an or there. That would be fine. Just different version. All right, how about questions on the sliding part? All right, how about another one? Let's do f of x. Maybe we should have done this one sooner. 2x to the -7. Same thing, just take your time. Derivative, we're gonna go right to the answer, to the derivative. Roll it down. There's a number there, so we multiply. So what's the first thing we're going to write? -14. And then x, just take your time with the subtracting 1, -8. And again, if we want to, you don't have to, the -14 could stay on top, the x could come to the bottom, making it positive. All right, let's see, we have some hard ones. What about, okay, let's do the picture. What about if f of x is 103.5? What is its derivative? It's a number, so its derivative is 0. Now, let's think about this. Who wants to think? All right. If I do a number, let's change it to a number we can work with. Let's do 4. What is that? Y equals 4. What type of line is that? It's a horizontal line. Y equals 4 is a horizontal line. What is its slope? 0. What did I just say here? Whether I do any constant, its slope is 0. It's not like magic, right? It all goes together, okay? Remember, the derivative is telling you slope. When I give you a number, I'm talking about a horizontal line. Its slope is 0. All right. How about if my number is 2 pi. Pi is still a number, so the derivative is still 0. Okay, pi is still a number, so the derivative is still 0. What happens if I write it like, a couple of ways they like to trick us. I don't know if I put this on the homework. What happens if they do like 2 to the 3rd? Do I roll it down and subtract 1? No, because it's on a number. Okay, so really, they should have really written 2 to the 3rd. They really should have written 8. So the derivative is still 0. Okay, so just be aware of that. What happens if they give us 2 pi x to the 3rd? This is just a coefficient. So when I roll it down, what is it going to be? 6 pi. When I roll it down, it's going to be 6 pi. And then it's going to be x. I shouldn't put equals there. It's going to be x squared. That's my derivative. So the derivative, roll it down, just multiply, the pi just kind of tags along, and then I still subtract 1. All right, we did all that. We did. How about let's do this one? Be careful on the homework. Every once in a while, they'll do f of t. So you just may have to make sure that you put t and not an x, which I always get wrong because I just always do x. But 4 minus 5/7 t. Derivative. Make sure you copy down. Derivative is 0. What's the derivative of this next term? If it's an x to the first, then it's just that number in front, or if it's a t to the first, then it's just that number in front. Same thing. This, what would have happened if I would have wrote this as y equals negative 5/7 x plus 4? This could be written like this. What? This is an equation of a line. I don't even care about derivatives. What's the slope? Negative 5/7. What happens if I implement the rule for derivative? We just did it up here, right? But this would go to negative 5/7, and this goes to 0. So it works for lines as well. All right, how about f of x? We'll go back to f of x, 1/3 x to the 6th. Roll it down, subtract 1, that's all the same. This one you might want to write, it's 1/3 times, it would be 6/1 if you want, and then subtract 1. So here I did my roll it down, subtract 1. Again, if you want to do calculator, you do it in your head, you don't even have to write that step. If it helps you to see it a little bit, this would be what, 6/3? Let me mark this as the derivative, which then takes us to 2. And again, you don't have to show that. You show as much as you want. Okay, we're going to be doing it all the time. So eventually, even if you show work now, eventually you'll probably drop it off. Okay? And if not, that's okay too. Okay, so what happens if we get to the, are we okay that that's the derivative? What does the derivative find us? Slope. So if I graphed this graph and I wanted the slope when x is 2, I actually plug it in here. That gives me the slope. And it's at some point, they just kind of started saying, okay, can I find this derivative, this expression that gives me slope for any equation imaginable? And so that's kind of what we start. We're going to do a few other things, but then we're just going to talk about new rules to address new equations or harder equations or different equations. All right, let's take a look at g of x. What happens if we are multiplying? Now, eventually we're going to have a rule. But sometimes on stuff like this, it may just be easier. How would I change this to a simple polynomial? Just distribute. Let's go ahead and just do the multiplication ourselves. So this is still g of x. Distribute. 2x to the 5th minus 3x. When you're multiplying, what do you do with exponents? You add them. So it'd be x to the 6th. Okay, now these two are still the exact same thing. Those two haven't changed. Now, can we take the derivative? Okay, so on tonight's homework, if there's multiplying, just go ahead and multiply it out. Make it a regular polynomial that we know what to do with. Roll it down, multiply, subtract 1. Roll it down, multiply, subtract 1. Too fast or okay? I mean, it's you know, I don't want to make it harder than it is either, you know, by writing a ton of things down. So roll it down. If there's something there, multiply, subtract 1. All right, how about same exact thing, f of x, if they give us x plus 4 and x plus 5. Right, up until now, we absolutely love that. But what are we going to do now? Go ahead and multiply it out. We don't have a rule right now for multiplication, and even when we get it, it's a little messy. So this is still f of x. Let's just change it to an easier form. A regular polynomial still, that maybe is the perfect child. That's still the thing we love the best. So FOIL first gives us x squared. Outer gives us 5x. Inner gives us 4x. And then last gives us 20. If you can do outer and inner in your head, that's fine. And if not, no big deal. X squared, if you remember 5 and then you can remember 4 and add that, then you can save one step. That is still f of x. Now, what is its derivative? Roll it down, subtract 1. Roll it down, subtract 1, or just 9x goes to 9, and the constant goes to 0. All right, how about, we kind of did this one. Let's try another one, f of x. 3x to the negative 5/6. Okay, I think we're doing pretty good then. Okay, so we've got 1, 2, 3. Oh, we got to talk about that. Okay, we'll do that, and then we'll save this other probably for tomorrow. Okay. All right. Same thing though, just watch your negatives, just watch your fractions, things like that, but the rule doesn't change. So roll it down. If there's something there, you multiply. Notice I put in parentheses, so I'm not showing subtraction. And then just take the time to minus 1. Say if you need a calculator, fine. You know, I mean, it might just be easier, go quicker. Otherwise, you got to do negative 5/6 minus 6/6, which takes you then to negative 11/6. Calculator is fine. You don't have to do that. And then same thing with multiplication. If you just want to multiply that in your calculator, you could multiply straight across. You could cancel first if you want. However you see it. Sometimes I just, well, should we cancel? 3 go, should I rewrite it? Do we see how this is 3/1 times negative 5/6? So negative 15/6 and then reduce, or 3 goes in there once, 3 goes in there twice. So negative 5/2. What was the other one I said? Negative 15/6. That should reduce to the same thing. And then x to the negative 11/6. Let's see, was it going to say anything? I don't remember, but, and you can just leave it like that. That's fine. And so just take it a little bit of extra time with the crazy ones. Let's do one more. I think we did one more like this, but let's do one more. G of x equals negative 15 x to the fourth, or I'm sorry, negative 15 divided by x to the fourth. This is really how they should write it, but what are we going to do? We're going to want to write it as, this is still g of x, we haven't taken the derivative yet. Negative 15, that's not going to go anywhere. And then we're going to write it, we're going to slide that up and make it x to the negative 4. And now, this might be a good one because we haven't seen two negatives officially yet. Roll it down, subtract 1. So negative 15 times a negative 4. And then just take your time with the minus 1 as well. Number one mistake kids say x to the negative 3. And I know you're probably like, oh, I won't do that, but you'll do it. We all do it. So just be careful, okay? Because yeah, you're going fast, especially if you've got 4 or 5 terms, okay? So it doesn't hurt, especially if there's a minus. It won't hurt to write that negative 1. As soon as you write that negative 1, you're not going to write negative 3. You're going to write negative 5. Okay? So it might be worth it to write that extra minus 1 sometimes. All right, and then this guy, because they're both negatives, the coefficient then takes us to, let's see. Here we could actually write the derivative, right? Here I finally found the derivative. And then the derivative, again, we'll just clean it up. 60, positive 60, because there's your two negatives, and then x to the negative 5. Again, where could we put it just so we get practice? The 5 could go to the denominator. This is the same as 60, and then an x to the 5th. Okay, we got 2 more. Now, don't tune out, because this is on the homework. Everyone comes to me and is like, I don't know how to do this problem. Yeah. Yes. Oh, yeah. Okay, so this one, yeah, there's a bunch of ways. But yeah, so you could do negative 5. Can we see it? Yeah, negative 5. And then we could do 2 and then x to the 11, 6. Yeah. You could even do something with a 6 root if you wanted to. And then you could even actually pull an x out, because if it's an improper fraction, there's actually some simplifying. But anything is fine like that. Yeah. Yeah. Does that work? Does that make some sense?
Yeah, I was curious why you didn't do it that one.
I don't know. Just sometimes my fractions, and then when I got another, even though it's an exponent, then it gets so messy that I just leave it. But yeah, plus there we could, like I said, we could even then simplify this. So we'll just leave it. All right, but it's a good question. You absolutely could, yes. Okay, so everyone write this one down. This is on the homework. X squared plus 4x plus 3 over the square root of x. You have to do one hard one. Okay, so this one, let me slide it to the top. This one's just a lot of work getting everything organized. So you're going to do x squared over x, and I'm going to change that right away, but we might as well in a step. The square root of x is the same as what type of exponent? 1/2. Plus 4x over x to the 1/2. And then plus 3 over x to the 1/2. This is still f of x. Oh, still f of x. Let's pause for, are we okay on that? You can split up the denominator. This happens a lot in calculus. We usually have this and we go to this. We usually like, if the bottoms are the same, we usually like to only write it once. But what if we created our nice individual terms? That's what we're looking for in calculus. So we'll go back and split it up. Because this is division. Do we have a rule for division? No. Make sure you don't try to go make one up yourself. I guarantee you won't think of, eventually we'll have a rule, okay? But it's not a fun one, okay? So don't make up your own. You got to break it up into individual terms. Okay, now how do we put these together? We can make this only 1x. What do we do when we're dividing with exponents? Subtract. So you have to do 2 minus 1/2. Okay, grab a calculator, or you got to get a common denominator. So that would be what, 3/2 plus subtract. This is an exponent of 1, so we're going to do 1 minus 1/2. So that gives us 4x to the 1/2. And how are we going to rewrite that last one? 3x to the negative 1/2. Have I done anything with a derivative yet? No, but look how nice. I've got 3 nice terms. Now I'm ready to go. But all of that, this is still f of x. But now I'm ready to go. Now I can finally mark the derivative. Now be careful here. I did some subtracting. This is what gets kids too. I did some subtracting here, but that's just because I was dividing. Okay, that had nothing to do with the derivative. Now I'm going to actually do the derivative, roll it down, and then make sure that now for the derivative, I always subtract 1. So what does that give us? That would give us 1/2. Roll it down, so 4 times 1/2, and then make sure that we subtract 1. For the derivative, you always subtract 1. 1/2 minus 1 gives us negative 1/2. Okay, and then for the last one, we've got the 3 times, roll it down, and then subtract 1. Negative 1/2 minus 1, negative 3/2. All right, and then we're pretty good. We could rewrite it one more time. This is one again where we could do some things, but I'll probably just leave it. So 3/2 x to the 1/2. 4 times 1/2 is 2. And again, if you need a calculator, that's okay. I'm okay with that. 3 times negative 1/2, negative 3/2, x to the negative 3/2. Can you read that? So, no one said it had to look pretty, right? But what will that give me? If I want slope on my original equation, way back up here, if I want slope at that equation, I plug it in here, and this will give me slope at that point. It's probably going to be some decimal because there's a bunch of square roots there, so I'll probably have to do some rounding or something, but it'll still be pretty accurate. Okay. So at least try it. At least you have an example. I know that one was a little bit harder. It's a lot of organizing. We got one more. Find the first derivative and the second derivative. 2 lines mean, okay, you got to see that. That's important. That means the second derivative. Second. We still could do a third derivative. We would put 3 lines. If I do something, I could write at the bottom here. If I put a little 5 and I'm technically supposed to put it in parentheses, that's what that is. That is the 5th derivative. So after 3, we don't keep making marks. We're not going to make 100 marks. Then we're just going to put a little number. You usually don't go past 2 anyways, but just FYI. Okay, so f of x, they make it basic. 3x to the 5th plus 2x to the 4th minus 7x. What is the first derivative? Roll it down, subtract 1. When you roll it down, if something's there, multiply. So 15x to the 4th plus, roll it down, subtract 1, 8x to the 3rd. And technically, I'm rolling a 1 down, so it would be -7. How do we find the second derivative? Take the derivative of the first, right? Take the derivative of the first. So we're going to roll it down. -15 times 4 gives us 60. Subtract 1. So that's, and now we're starting all over. So now we're just taking basically the derivative of this guy. Roll it down. Subtract 1. And the number derivative goes away. When you get to physics, the second derivative is acceleration. We'll talk a little bit about that here, but then we'll leave that for the physics guy. Okay. But just so that you know, there is a little bit of purpose to that second derivative. Okay, so homework. Don't do the last problem. The last problem we'll have to carry over till tomorrow. Okay, so make sure that you tune into the last problem for tomorrow. Okay, maybe I'll shorten up tomorrow's homework. Tomorrow's homework isn't long, and Friday's is even shorter, okay? Because you have to know this rule. Make sure by Monday you have done every single one of these problems on this lesson, okay? Leave the last one, though, for tonight. Okay, don't do the last one. All right. Have a good day, guys. Not going away. You're going to hear this in your sleep. Roll it down, subtract 1.